Hi friends, today we are going to learn SIO. SIO is a chip who manage the entire system of the computer or the laptop. He manage the power, he manage the temperatures, he manage the fan, then keyboard, then touchpad, then lead sensor. So many things manage, and in laptop or in the desktop, the first component which is going to power on is SIO. SIO is sometimes called the KBC, that means the keyboard controller, or sometimes called the EC, that is embedded controller. In schematic diagram, when you open the first page, it's mentioned over there EC, that means embedded controller. The SIO is manufactured by all of these companies. Either it is Winbond, IT, SMSC, Newton, or ENE. When you open the motherboard, you will find a chip as a mention either of these manufacturers. So this is the SIO, and what are the things required to run the SIO? That is, first of all, he need the power. The SIO need approximately a 3.3 volt to run, that is a VCC voltage. And the second thing is SIO's need is reset signal, that is called the EC reset signal. This is a resistor capacitor RC circuit. It generates the delay over here, and this is called the EC reset. So here should be a 3 volt within a few milliseconds. And the next thing is require SIO to run, that is a clock, that is a 32.7 kilohertz. In older motherboards, this 32.7 kilohertz generated by self SIO connected with the crystal, 32.7 kilohertz crystal. But now in the newer motherboards, this 32.7 kilohertz clock generated by the PCH, that is called the RTC circuit, and that PCH delivered this 32.7 kilohertz to the SIO, that is called a sys clock, that we'll see on the later. So this is SIO. Now I already told that SIO do so many function, and the first component which is going to on in the laptop is SIO. SIO manage the battery, SIO manage the EC bias, manage the keyboard, touchpad, on off switch, lead sensor switch, turn on the USB and on off, then drive the fan, and he communicate with the PCH through the LPC bus. Now SIO have 128 pins, like this is a pin number 1, and pin number, it start from 1 2 3 4 like that. This is pin number 32, then 33, and it's go on like that. It goes anti-clockwise. The number is mentioned here is like a KB3910 is a number, and nowadays the EC bias is inside the SIO. So this SIO is called the programmable SIO. So if it is your laptop is dead and you are going to replace the SIO, then you need to flash the SIO, and these are the manufacturer, these are the numbers of the SIO which that you have to program. Okay, so these are the programmable SIO, and the previous that all the SIOs are non-programmable, but these all the SIOs are programmable in any IT, Newton, and SMSC. Now I'll tell you which are the important pin to turn on the power if you have a laptop which is a dead. So which pin you have to check? First of all, you have to check power on the SIO, that is a VCC pin. You have to check on the diagram, so which is your VCC pin, you have to check VCC voltage over there, that is a 3 volt, that is number 1. Then number 2, SIO need a reset signal, that is a EC reset. You have to check a 3 volt here, that is a EC reset. And the third important signal is a thermal trip. The signal should be a 0 volt. So these are the three main criteria. Then fourth is a sys clock also, or the clock also. The next is, these are the signal who are responsible to turn on the laptop. First of all, it's called the power button. It's sometimes called the NBS on button, power button. So here the voltage is 3 volt and the next point is connected to the ground. When the switch is connected to the ground and release, that time the 303 volt pulse will be generated at this terminal on this NBS on pin number. So when he received the SIO, when he received this pulse, at that time SIO send out the signal that is called the RSM RST. Before pressing the power button, the RSM RST voltage is 0. When you press the power button, the RSM RST voltage goes to 3 volt. The next thing is the PM power button is called the DNBS on button. This is called the power out signal to the PCH. He generates a 303 pulse to the PCH. So that means he is saying to PCH to turn on the laptop, give the confirmation. So it like that. If this signal is not coming, or if this signal is not coming, then possible fault could be SIO may be bad, or if the EC bias is connected inside the SIO or outside the SIO, that may be faulty. So you have to check either of this signal. The next thing is the SLP S3 and SLP S4 signal, slip wake up signal. These are the two wake up signal coming from the PCH. So when this power button is pressed, then SIO send out this PM power button signal to the PCH, asking the confirmation to turn on the laptop. That time PCH send this two signal, SLP S3, SLP S4, and when SIO receive this signal, at that time SIO turning on the power supplies like that. And if these signals are not coming, sometimes it's called the SUSB or SUSC also. These are the alternate name of the SLP underscore S3 and SLP underscore S4. This is wake up signal. So if these signals are not coming, then possible fault could be my PCH, or if the CPU, if the 4th or 5th generation onwards laptops are there, then the possible fault could be the CPU. So in this way we see how to check the dead laptop. What are the signal on the SI? We have to check if the laptop is dead. And if the 3 volt is not coming, then you have to go the always voltage section. Why it's 3 volt is not coming, just like that. So next fault is no display. If you have a laptop power on but it's not giving a display, and you have to check this 3 signal on the SIO. The first signal is called the PLT reset or the platform reset. When laptop is turned on, all voltages are generated. At that time SIO send out one signal that is called a EC power OK signal. Once PCH receive this EC power OK signal, PCH send out a platform reset signal to the entire motherboard. At that PLT reset, you can check on the SIO also. This normally connected to the LPC bus. The next signal you have to check the clock. This signal you have to check by oscilloscope only. 33 megahertz coming from the PCH. If this signal is coming, then clocks are generated. If not coming, then maybe the PCH may be faulty, or the 25 megahertz crystal connected to the PCH, that may be the faulty. So you have to check this signal by the oscilloscope. The next signal is called the frame signal. This 303 pulses coming to the SIO from the PCH. If this signal also you have to check from the oscilloscope. If this signal is not coming, that means the possible fault could be my CPU or the PCH, like that. So these are the 3 signal. If the laptop is power on but not display, then these are the 3 signal you have to check on the SIO. The next fault is a battery. If the battery is not charging and it's battery giving faulty, and suppose you have to change the battery but still the battery is not charging, and all the voltage sections are okay but still the battery is not charging, then you have to check these 3 signal. The first signal is called the AC in signal, that is a adapter current in, this signal coming from the voltage section department. And the next, these 2 signals are called SM bus. It's called the system management bus. It's communicating with the battery. It's a communication like the see in this diagram, you can see it's communicating with the battery. So these are the important pin when if the laptop is dead or power on. Now We are going to learn all the important pin on the SIO. So this is a SIO and these are the pin. So we are going to check. We'll start from this. These are the supply. Either it's called AVCC, VCC, VDD. This is supposed to be a 3 volt should be coming on the pin of the VCC. The next signal is called the EC reset. It's supposed to be a 3 volt. Okay. The next signal is called the lead closer switch. The lead closer switch is a magnetic sensor which when you open a laptop or close the laptop, that time a magnetic sensor generate the current, and that current received by the SIO is called the lead closer switch. If your laptop and it's not giving a display, but if the external display is okay but internal display is not coming proper, it's not coming, then you have to check this signal, the lead closer switch. The next signal is called the USB on. The USB on is a signal when your USB is turn on turn off. You can turn on and turn off the USB by through the SIO. So SIO generate this signal. The next, these two signals are it's connected to the touchpad. This is called the TP data and TP clocks is a 2-wire communication to the touchpad. This next signal is called the processor hot signal. It's coming out from the CPU side processor. If the processor is very hot, then it generate a 1 volt here. At that time SIO receive this signal and turn off the power. Okay. And the next signal is called the EC power OK or PCH power OK. The EC power OK or the PCH power OK is a signal sent out by SIO. If this signal is coming, that means your all powers are okay. Your all the CPU core, graphics core, 1.05, 1.8, 3.35, all suspend voltage are coming perfectly. He sent this signal to the PCH and then PCH send out a PLT reset to the entire motherboard. This is a very important signal. If you have a laptop, suppose it's not it's power on and off or something issue with related to the display, then also you can check this signal, that EC power OK. This next signal is called the sys power OK. Sys power OK means suspend power OK. It's coming from suspend section. Then this signal is called the IMVP power good or the VRM power good or the V gate. These are the 2 or 3 names. The definition of this signal IMVP power good means the core voltage is perfectly alright. The CPU core voltage is working fine. So it's meaning of that signal. If you have a laptop, suppose something related to the problem with the CPU core section, then straight away you can check this signal. So first of all, this VR out comes out from the SIO. You turn on the core voltage and then the CPU cores department send out this signal, that is called the IMVP power good. The next signal is called the suspend on. These are all the red color, all the signal are related to the power. This very important signal related to the power. So like that, this is called in earlier slide we seen the NBS on, the power on button. This is the actual power on button which we press and it goes to the SIO. It generate a 303 pulse. Then DNB on or PM power button is a power output or digital power output. It send signal to the PCH and then the RSM RST signal is to the PCH. So these are the 3 signal. Then SLPS5, SLPS3 and SLPS4, these are the 3 slip wake up signal input to the SIO. SLPS5 signal is generated normally for the turn on the always voltage. SLPS4 signal is normally turn on the RAM voltage, and SLPS3 signal normally turn on the system voltage and for the CPU core voltage, like that. This PCH power enable signal, this signal is basically used only in Compal motherboard. When you press the power button, at that time SIO send out this PCH power enable signal. and these are the three main signals. That is called a suspend on, main on, and power on. When you press power button, when you SIO receive this two signal SLPS3 and SLPS4, at that time SIO send out this three signal one by one, that is a suspend on, main on, and VR on signal, and turning on the entire laptop. So you have to check signal one by one. Okay, so my next signal is called the sys clock. Sys clock is a system clock. When these are the two optional signal. If the SIO connected, suppose crystal is connected to the SIO, 32.7 K crystal is connected to the SIO, then sys clock is not required. But if this crystal is not connected, then the sys clock is required, and this clock send PCH to the SIO. This frequency is 32.7 kilohertz, and this signal you can check by oscilloscope. So this signal is gone ground, and EC on signal is basically used on the fifth generation to turn on the 1.8 and 1.1 volt 1 volt. Now we'll go to this side. Okay, so we'll start from this side. So Wi-Fi enable. So Wi-Fi enable signal, SIO turn on Wi-Fi, enable or disable by sending this signal. This signal goes to Wi-Fi card, that slot pin number 20, and when we turn off Wi-Fi, that time this voltage is 0. When we turn on Wi-Fi, that time this voltage is 3 volt. This next signal is called the thermal trip. Thermal trip, when the CPU is very hot, at that time this signal is generated and turn off the entire power system. HWPG. The HWPG is basically used in only on Quanta motherboards. There are 2 or 3, 4 types of motherboard, like a Compil, Quanta, Wistron, Foxconn, Inventec. So in Quanta motherboard power sequence, you will find this HWPG signal. The HWPG signal, the means of this HWPG signal means when the all powers are okay except the CPU core, this here is a 3 volt is generated, and when is 3 volt is generated, at that time SIO send out this VR on signal and turning on the CPU core section. If one of the voltage is absent, either suppose 1.05 or 1.8, either of any voltage, if it is absent, then the SWPG will not be generated. Here it will be 0 volt only, and so core voltage will not turn on. So this signal is very important, but this signal is basically used in only in Quanta motherboards. This next two signals called the fan-sing and V-fan. The fan-sing is the output signal to drive the fan. The fan is connected to the 5 volt via a MOSFET, and that MOSFET gate driven by this fan-sing signal. When the temperature is high and CPU is very hot, that time SIO trigger this signal to that MOSFET, and then MOSFET releases voltages to the fan, and fan started rotating. You can see in the another slides also. And this is a V-fan signal. The V-fan signal is the input signal to the SIO, saying what is the rotation of that fan. The fan is, that is called the RPM. What is how the fan is rotating. The all information fan is given to the SIO. So these are this two signal basically used for to manage the fan. This is called the SM bus, system management bus. Is a two-wire communication protocol. This two-wire communication protocol communicate with the battery. It's called the SM bus. When battery need a charge, or suppose adapter is absent, at that time battery communicate directly to the SIO via this two-wire communication. So this signal also you can check by oscilloscope. These are the two AC in and AC present signal. AC in signal coming from the volt in section, adapter section, and here will be 3 volt. If it is a 3 volt, then my laptop is working on the adapter, and if the voltage is a 0 volt, then laptop maybe in the battery. The next signal is called the AC present. SIO send out this signal AC present, and this signal is called the temp bat. Temp bat is a signal coming out from the battery saying the temperature of the battery, what is the temperature, so SIO monitor the temperature of that battery. Then these are the four signals called write, read, chip select and clock. If the SIO connected to the EC bias or EC bias is connected with the SIO, at that time SIO connect this 4 wire to the write signal, it goes to pin number 7, read signal pin number 2 of the bias, and chip select, this is a chip select connected to the pin number 1, and clock pin number 6. So it's like that. The next signal is called the keyboard. The keyboard is driven by SIO, managed by SIO. There are 24 line, 30 lines keyboard pins are connected to the SIO. And the last, this section is called the LPC bus. This bus is connected to the PCH, and these are the signal. First signal is a PLT reset, platform reset. That's the reset signal. When all power turn on, that time PCH generate this platform reset. And the next signal is called the clock signal generated by the PCH, and this is the 4 wire communication to the SIO and the PCH is called the LPC bus, and the last signal is called the frame signal. So these are the important pin on this SIO. Thank you very much.